Hello friends, welcome to another video on my YouTube channel on context management videos, and in this video we are going to cover memory pruning demo. So in the past videos we have seen sliding window approach and summarization approach to maintain your conversation history. In this video we are seeing something different where we will be calculating importance of each messages, and based on the importance we are deciding which message we want to retain in our memory and which we do not. So in the last video, we saw sliding window approach, which had a problem of removing important instructions if they are present at the start of the chat, as well as the summarization. In the summarization, there could be a problem where, let's say, you have a huge chat history and most of the chats are like not very important to you. For example, they are basically greetings or random chats or things like that. Then you will be summarizing each and everything in your summary, right? You will still have some unimportant decisions or unimportant contexts or chats in your summary. So to avoid that, we have a different approach which is called importance scoring. So here we have again the same method, which is estimate tokens, the same approach that we have taken in the previous videos. We divide the total length of the text by 4. Then we have a new function called importance score. Again, I'm just using the hard-coded implementation here. Further in this video, I'll show you how to integrate it with the LLM as well. So first, let's go with this hard-coded implementation where I am giving a score to a particular message based on what is present in that. For example, let's say if it contains something like this, my name is, or remember, or a decision, then the importance of that particular message is high. For example, for these kinds of messages, I am returning the importance score as 10. Then for some decisions or something related to projects and everything and references, I am returning the importance as 9 and 8. Then explanatory things, I'm returning the importance score as 7. And for all the other greetings like thanks, thank you, okay, hi, hello, and everything, I'm returning the importance score as 1. And if the length of text is less than 15, I'm returning it as 2 and default as 5. So obviously, this you can modify on your own. And this is also not a very good way to define this function, because as soon as the conversation will change, this will not work, right? So it will just only work on some hard-coded conversations. So we will see in the further videos how we can use LLM to decide the importance score of a particular thing. So again, now we have a data class memory entry where we have messages and the tokens that this message will contain. Now we have a new entry which is called importance, how important this message is, which will be calculated using this function. For example, if the message is high, then the importance is 1. If the messages contain some decision about the project, then the importance will be 9. Based on this importance, at the end we will decide what we want to keep in our memory and what we do not want to. Now in the init function of our memory pruning history class, we have max tokens as we have seen in the previous videos. We have entries, which is this again the memory entry, the list of messages, then current tokens and the total tokens removed. Now in the add messages function, I'm not going through all the functions again, because this again contains a base chat history message class, and this will contain all those 5 to 6 functions again and again. The only difference is in add messages function. So I'll be just going through that. So for each message that we are getting in this add message method as a param, we are creating a memory entry where we are storing the estimated tokens and the importance score that we are calculating using this method for that particular message. Then we are appending it to the total entries, and we are adding the tokens that are present in that message to the total tokens that we are maintaining in our class. Now again, if the current tokens exceed the total limit of the tokens that we have set while initializing the class, then we are doing the pruning. So this is just for demo. We are just printing it first, then pruning it, and then we are again printing it. In the prune, if you will see, it will be deleting the messages based on the importance. So while the current tokens are greater than total number of max tokens, this loop will iterate. So we are first sorting the entries based on the importance and then the number of tokens that are present in that particular entry. So our entry contains two fields, right? Tokens contains the total number of tokens that are present in this message, and importance contains the importance score of this message. So first we are sorting our messages that are present in this list, in the current list, which is here, based on importance than the tokens, because importance is the first criteria that we'll be using to optimize our memory, then the total number of tokens present in that message. After we have sorted out this whole list, we are going to remove the first entry from it. So as you can see, after sorting it, we are just taking the first entry from this whole list, and we are going to remove that from the list that is present in the entries. Also, we are just updating the current tokens by subtracting the tokens that the message that we are removing contains. So this removal is again an entry, right? By entry, I mean this data class. This variable is again a object of this memory entry class. It contains the message, the tokens for that message, and importance, right? So the message that contains the lowest importance, that is getting deleted, and we are subtracting the tokens that are present in that message that we have calculated already from the current tokens that we maintain. Also, we are enclosing the count of total removed plus 1. So this will keep on happening until unless the current tokens value is less than or equal to the max tokens limit that we have initialized in the class. Now, as you can see here, we are not doing any summarization or not using sliding window approach. So it may happen, for example, first a user is saying something like my name is this, then maybe it's saying thanks, right? So because the importance of sentence my name is 10, and a sentence that contains thanks or something like this, importance of such sentence is 1, it may happen even if the sentence that is coming afterwards will get removed first, because its importance is low in the whole conversation memory, in the whole conversation history. So here you are just keeping the messages that are more important to you. You're not keeping all the things, all the random conversations in your chat, because those are not needed while the LLM is making decisions. Only the things that are more important to you, you are keeping that in your memory and you are passing that to the LLM. So you can just go through this method again. It's pretty simple to understand, because we are just sorting it based on the importance and tokens, and removing the messages one by one until the total number of tokens gets below the total limit that we have set. Then again, we have same printing methods which we use to show memory, show uses, and show statistics. Now this is our demo where we are creating a memory pruning history class with maximum number of tokens as 100, and this is our whole conversation, hard-coded conversations I am using again. So because I don't want to integrate LLM here, you can do it yourself if you want. Now for each text in this conversation, I'm just calling the add user message or add AI message based on the role present here, and then I'm showing the memory and the stats at the end. Let's just run this block. Now as you can see, this memory pruning demo, initially we saw a hello message, right? So here we have a hello message and then hi message. So this usually contains one token. So the number of tokens are increasing based on the sentence, the length of the sentence. Then my name is Shubham, nice to meet you. Let me make it scrollable. Let's go to the top. So as soon as the messages are coming, the number of tokens in the current memory is increasing. So until this point, everything looks fine. Now, after this sentence comes, the total number of tokens exceeds the maximum limit that we have set in our class. Now, before pruning, before clearing our memory, this is the state our memory is in. We have all these messages as a list. So as you can see, the last message is present at the end, and initially we have hi and hello, right? So these are present at the top. Now you can see importance of hi and hello is 1 and 2. Importance of the name and this sentence is 10. This is 5. Thanks is again 1. Then I'm building a AI project. This is 8. Then decisions and everything are coming under as importance 9. So this is coming as 5, 6, and then this is coming again as 5. Now after pruning, let's say, so it's removing the messages from the least importance, right? So it's removing the messages which have importance as 1 first. So as you can see, these two and this one. So this has importance 1, hello, thanks, and I. These have least importance in the conversation, right? So it's removing the first these 3 messages. Then again, it's removing the messages from the next least importance. So after these 3 are removed, the least important message to us is I think This one only. Let me check. Nice to meet you. What is the importance of this? 5. So after 1 and 2 are removed, the next messages that have least importance are 5 ones, right? Which is nice to meet you, and this one, Postgres is an excellent choice, and all these things. So it's removing these two as well. Nice to meet you and Postgres is an excellent choice and all these things. Because this is also not a decision, right? So I just kept the function hard coded according to the messages I am providing, right? So we'll see how the LLM works here. So now, as based on the importance, it's removing the least important messages first. It's not using any order, or it's not removing the message from the first or last. It's removing the most least important ones and keeping the more important one in your memory. In the memory now we have, my name is Shubham. I'm building a AI project. Great project Postgre will be a database, explain embeddings and all these things because they have high importance. All the lower importance messages are gone from the memory, and then you have just the decisions and main conversation in your memory history now that you can pass to LLM, and most likely will LLM will gather all the context from it because the messages that you are deleting are least important. Like they may not provide much context to the LLM. So this is how you are optimizing your memory to keep the most important decisions that you are making in the conversation history and deleting what is not needed. So after that, the messages came again. Now this is again our context limit reached. Now again, before pruning, we have these messages in our history. So last time we had this thing, embeddings one. After that we got 3, right? So again, OK has an importance of 1. Then these two have an importance of 10 and 10. So now when we will be deleting the messages, this will go first, right? So as you can see, the first OK is going, even though the OK came after these messages, right? OK is going before because it has least importance. After that, we are removing the next least important messages, which is 5. I think let me search here. After 1, we have this 5 as the least important message. As you can see, this is getting removed next. And after pruning, we have this memory. We have this chat as a conversation history in our memory, which we can again pass to LLM. So this is how this important selection and memory pruning works. So here you just keep the messages what is most important to you. So as in my previous video, I told you to integrate LLM with the summarization approach on your own. I hope you were able to do that, but if not, I'm going to integrate the LLM here in this particular approach, and you can just take the reference from it to integrate LLM in the summarization approach as well. So as you saw in the previous implementation, my importance score method was a hard-coded one, which was like looking for some keywords in the sentence, and based on that it was like scoring the importance of the sentence. But that is not an approach that you can use in a real world environment, right? So here we can use LLM to do that. So here we have memory evaluation. So we have importance, we have category, we have should keep as true or false. Here we have reason. So all this will come from the LLM. So in the memory entry, we have some new properties. We have message, token and importance addresses. Now we have category, should keep and a reason. All these things will be provided by the LLM to you. Now instead of a hard-coded implementation of getting the importance, we are using LLM and we are using this prompt to define the importance of a message, and we are asking our LLM why we should keep this message and whether we should keep it and what category it falls to. So if you will go through this prompt, you are an expert AI memory manager. Your job is to decide whether a message is worth keeping in long-term conversation memory. Importance scales are 10, where we have permanent user facts like name, age, location, profession. Then 9 contains critical decisions, project architecture, requirements. 8 contains preferences, goals, current projects. 7 contains useful technical discussions. 5 contains general conversations. 3 contains temporary informations. And 1 contains greetings like thanks, okay, small talk. To evaluate the following message, we are passing the message here, and we are using this. We are just modifying this class to use this prompt to invoke the LLM and define the importance of the message. Now in our add message class, for each message we are evaluating the message. So in the evaluating message, we are just invoking the LLM, which the LLM we have defined here. So this LLM is the open router LLM object that I have defined at the top. And if you remember from my previous video, I'm using a with a structured output here to get a structured response from the LLM. Instead of using any parser or something like that, I'm using the with structured output for this demo. So in this, I'm providing a memory evaluation schema definition class. So from my LLM, I will just get an importance, a category, a should keep as a bool, as a boolean, and as a reason. So my importance is the score which I have defined here, like 10, 9, 8, 7, 6, like that. Category is the type of memory. Then should keep, whether we should store this message or not, and the reason for that. All this will come from LLM in the form of a JSON, because I'm using it with the structured output, output of LangChain, and integrating with the LLM. If you want to learn about this, you can just check my previous videos on the memory, where I have explained different types of memories as well as the with the structured output. Sorry, different types of parsers as well as the with the structured output. This is a parsing type. So we have an LLM here, we have a prompt here. Now in this method, we are just invoking this LLM using this prompt, and we are returning the answer. Now for each message that is coming inside our add messages method, we are calling this evaluate message method with the message, and here this message is going to LLM in this variable format along with this whole system prompt, and whatever is coming from the LLM, we are just returning it. As you know, we are using the LangChain, right? So it will just return us a string in the end. This memory elevator, this is coming from LLM, right? So this LLM is a chain. This is LLM as an open router LLM. So this will be a simple output. Once the output comes from the LLM, we are using that to build our memory entry and data class, which is containing the message estimated tokens. Estimated tokens, we are again using that divide by 4 approach. Then whatever importance the LLM has given to that message, category, should keep, and reason, and everything. We are creating our memory entry here, and we are again doing the same thing. We are increasing our current tokens, and if the current tokens increase the maximum number of tokens allowed, then we are pruning the message. In the pruning, we are again using the same approach. We have just one more reason here. So we are just sorting the messages first based on should keep. We are just keeping the messages which are on the top, which LLM is saying we should keep on the top, then on the importance, then on the total number of tokens. So same approach, just a different params we are providing in different in the sorted function. After that, whatever message is coming as the top, that can be removed. We are removing that. We are reducing the current tokens from the by decreasing the tokens that are present in that message, and we are just iterating the loop again until the current tokens become less than the maximum number of tokens allowed. So as you can see, this whole implementation is similar, only we have just an extra variable called should keep, which LLM tells us that we should keep this message or not. In the sorting function, everything else is same. We are just calling LLM to evaluate the importance and the reason if we want to keep that message or not, instead of hard coding it. So similarly, you can call the LLM in the summarization approach here. Like you can just create a prompt where you ask the LLM to summarize the following conversation and keep that summary in your summary variable instead of hard coding it. So let's quickly go down. These are all printing methods, and this is how we are calling it. We are creating the class with 100 maximum tokens. I'm passing the exact same conversation that we have passed above again, and let's see how this behaves now. So let me just quickly run it. Something went wrong. LLM is not defined. Huh? Let me just quickly go to the top and put myself. So this is somewhat here. Let me just quickly go to the top. I've defined the LLM the top of this notebook. So let me quickly run this cell, run this cell. So as you can see, this is my LLM object. So where I'm using the chat OpenAI method provided by the LangChain, and I am using GPT-4o mini LLM model. Maximum number of tokens also I have defined here as 500. So let me just increase it to 2000 maybe, and run this cell again. So let's quickly go down. We go down, and let's try to run this again. Now this time it is running, I hope. Let's go down. Yeah, now this time it's running. So hi, my name is Shubham. Nice to meet you and all. Let's quickly It's running, still running, okay, because I'm using LLM, right? Now it's taking more time to run this whole block. So it took 18 seconds now. Now let's make it scrollable and analyze from the top. So the number of messages are increasing as more messages are coming. So 21, 24, 34, 73, 131. Now the limit reached here with this embedding one. So as we are again using the same token count divided by 4 approach to count the tokens, it's the limit is reaching at the exact message that we have seen in the on the top. But the importance and everything that now it is coming from the LLM. As you can see, hello and hi are again coming as one from the LLM as the importance. And the importance of my name is Shubham and nice to meet you is 1, name is 10, thanks is again 1, I'm building a project is 8, great project 5, decision is 9, this is 7, and explain embedding is 7, and this is 7. So I think it's a bit different, not much different, because the conversation is very hard-coded one. So if I go to the top, I think the Postgres SQL was 5. The response, just let me check. So yeah, this Postgres is an excellent choice. It's a mature, reliable source and everything. This is like 5 here, right? But I think in the below approach it is 7 because it's now coming from the LLM. This is a technical discussion, right, about Postgres SQL. It's not taking it as a general conversation. It's taking it as a technical conversation, and hence it's coming as 7 now. So if I just go down, so yeah, as you can see, the importance is coming 7 for this one now. So let me just do one thing. Let me just print should keep as well as the reason. Let me just modify things a little bit. So what we are doing here, let me just make the changes here to print should keep as well. So this is importance, this is tokens, and let me yes. So this E is coming from, I think, the entries. Yeah. So E dot should keep. I hope the, and then reason. Let's do this reason as well. Now let's run it again. Let's see what the reason and variable should in the variable should keep is coming. It will just again take few seconds to run this whole block. Let me make it scrollable and analyze from the top. So till now everything is okay. I think it is running. Let it run first. Yeah. So everything looks fine. Here again the limit reached here, and now we have this. So as you can see, okay, the reason is pretty long actually. So for hello, the reason is this message is greeting and does not provide any valuable lasting information for the future conversations. So as you can see, for hello, for hi, it's saying something like this, like this is a basic greeting and does not provide any valuable information. That is why the importance is 1 as according to the prompt. Then name, this contains effect, right? The permanent user effect. So it is 10 and it should keep as 1. Now again, what is nice to meet you and thanks, all these are like again greetings, gratitude, and does not provide any valuable information. So that is why the importance is 1. Let's look into higher ones. For example, this one 8. So the message was, I'm building an AI travel agent project, and then great project. So this is relevant to future discussions and understanding the user's goal. So this is user goal, and this is not containing the great project. This is just the great project thing, right? So here the importance is low, here the importance is high. Then 9 is, I think, the Postgres SQL conversation. Yeah, this is the decision, right? So this is a critical decision. That's why this is keeping it as high. Then this message provides a valuable opinion on Postgres. This is the opinion on Postgres SQL, right? So this is a technical doc. So this is why the importance is 7 here, and same for other two, embeddings and vector representation and everything. All these are coming from LLM based on the categories that you have provided in your prompt. So this is a much better way to calculate the importance of a message, because nothing is hard coded here. Even if something comes new, then LLM will be able to find out the importance for you like as easily as all the other things. So now we are removing the least important ones like hello, hi, thanks, nice to meet you, great project, can you explain embeddings, and things like that, right? After that, we have these 4 in our memory now. which is my name, and then building a project, and then uh, Postgres choice, the message which is one Postgres SQL will be database, and embeddings are numerical vector representation. So these are present in our memory now. So as you can see, most important decisions and most important things are only the ones that will be present in your memory once the context window limit is reached, right? So this is how you can use this approach. So now the messages came again and 99 by 100. So now the limit didn't reach, right? So your final memory after the whole conversation is like this. Now, as you can see, it does not contain any irrelevant information like hi, hello, great project, and all these things. So okay is there because this was a new conversation. So next time when the pruning will happen, these ones will go away, like the okay and last two ones. I think these are like thanks and all. Certainly, I'll remember it. Thank you. All these things. The next time, these will go away first. So this is how you can use LLM for summarization as well as for importance scoring, and you can just optimize your memory in a better way. So there are other approaches as well that you can take for summarization and different hybrid approaches as well, where you can first define the importance of each messages and remove the messages of least importance, and then summarize the most important ones. Like if you want to reduce the memory further, right? So you can use the hybrid approaches as well. So we'll see all that as an actual implementation in further videos. For now, just go through it and try to integrate LLM with other two approaches as well, with the summarization approach as well. Sliding window doesn't need LLM, right? Because it's like a simple thing, removing the oldest message. So try to integrate LLM with the summarization approach. Try to create your own system prompt and see the result, how the things are behaving then. So till that time, please like, share, and subscribe, and have a nice day. And we will see more interesting things in the upcoming videos. So after this memory is completed, I'll be moving to the RAG and agents, and we'll see more interesting things there. So please have a nice day and thank you.